a non-positive quantity because x is not equal to 1.
So can't you just solve it in x minus
Exactly. I can just can I multiply them out?
No.
No. Okay, what did you say? Can you just repeat it?
Well, can't, since the bottom is non-negative, then
Mhm.
you can just solve it as x minus 1 is greater than or equal to.
You mean this?
Yes.
Yeah. So what do you get out of that? Do you get the solutions they say that?
No.
Okay. So you have this is absolute value is greater than or equal to 0. That's always true, right? So only value it cannot take is this value because this becomes 0. Okay? But this thing is true for all x by the definition of absolute value itself. Okay? So all values of x other than 1 are true for this equation. Okay? So that's a true. Okay. Second problem. Anybody did the problem?
So just that 4x plus 3 is greater or equal to 1? Because it has to be positive.
You can't say greater or equal to 1. First thing to observe is x is not equal to minus 3 by 4. That should be your first observation. Whenever you are solving an equation, make sure to find out the values of x for which it becomes 0, because in that case x cannot take those values. Okay? In case it's a reciprocal. How many of you could solve the second problem? Okay, let's first do the third problem. If you get time, we'll get back to the second problem. Okay, so what's the leading coefficient out here? It's negative x, right? What about here? Not exactly. You have 1 minus 2x whole square, right? So if you break it out, what did you get? So what's the leading coefficient?
4.
It's 4. In fact, if you write this way, it's 4x squared. Right? What about here? Not exactly. You have a cube here. It's negative x cube. If you break the cube, what did you get? The highest power of x, you'll get x cube, and you have a negative sign before it. What about the leading term out here? You have a power 4, x to the power 4. And what about this? Yeah. So if you multiply them out, what did you get? Yes? These are the leading terms, right? So if I want to look at the leading term of fx, I'll just multiply them out and see what the leading term of fx looks like. Yeah. Two comments regarding your projects. One is try to work neatly, okay? You'll have, I saw something like this. One of you wrote a by 2 like this, and in the next line here is a, and third line you ended up doing a square. So it was a by 2. You crammed in a here, next line, and next thing you did on the third line was taking it to be a square instead of a. So and you lose a point because you get the whole problem wrong there. So for your next project, at least work neatly. Don't cram in whole of your project in just 2 pages. And second thing is you better start working on your projects. I reminded you last week because you have how many, more than 100 problems?
When is it due?
It's due November 15th, I guess. Let me check.
It's 15 points still?
Yes, it's 15 points still. I didn't. I'll probably not take the hardest problem or the most difficult ones in your project, but that doesn't mean you won't give it a try. I left out the most difficult problems here in this project as well. But still give it a good try, all the problems, and better start walking right from now. So now let's get started with the worksheets. Can anyone explain what's the extended cancellation law? Question number 2, third part. Some random guess? Something to do with inverses? Okay, let's take an example. Suppose I want to find this out. Okay? Now, what do you feel like doing when you see this? Well, you want to cancel, right? Next question is, can you cancel? Why? Because it has to be in the interval of definition. Is this what's the interval of definition for sine? Right? So these two quadrants. And where is 3 pi by 2? So it is here. So what do? If you want, you can't cancel because this angle is outside this domain, this interval. So what you need to do is, you need to find an angle inside this interval. Okay, such that, okay, let me write it down. Find theta 1 belonging to this. Okay, S dot t stands for such that